Before we begin, a critical disclaimer. The information provided in this video is for educational and informational purposes only. It is not a substitute for professional advice from a licensed, insured, and qualified commercial electrician. Electrical systems are complex and potentially lethal. All work on your commercial property's electrical system must be performed by a certified professional who is compliant with all local, state, and national electrical codes, including the NEC, right here in the United States. Your safety, the safety of your employees, and the viability of your business depend on it. A fire marshal once told me something I'll never forget. He said, "No business owner ever thinks it'll be their building, until it is." He just walked out of the charred shell of a beloved local restaurant. The cause? A faulty electrical outlet in the kitchen that the owner admitted had been acting up for months. He just kept plugging the mixer into a different outlet, thinking he'd get to it later. Later never came. The fire started at 3 a.m. By sunrise, a 20-year-old dream was a pile of ash and a heartbreaking insurance claim. This isn't a scare tactic. It's a reality check. According to the National Fire Protection Association, electrical failures are one of an absolute top leading causes of fires in commercial properties across the USA. We're talking about offices, retail stores, warehouses, restaurants, maybe a business that looks a lot like yours. These aren't just statistics. They are businesses lost, jobs vanished, and lives turned upside down. And the most terrifying part? The vast majority of these disasters could have been prevented. They started with a small sign, a tiny warning that was misunderstood, ignored, or simply unseen. That's why you're here. Because deep down, you know that the hum of your servers, the flicker of your fluorescent lights, and the maze of wires behind your walls are the electrical lifeblood of your business. And if that system fails, everything stops. Productivity, sales, security, everything. But you're also probably not an electrical engineer. You're a founder, a manager, an entrepreneur. You're focused on growth, customers, and operations. You don't have time to become an expert in amperage, voltage, and three-phase power. You don't have to. Over the next several minutes, we are going to give you that expertise. We are going to arm you with the critical knowledge to protect your investment, your people, and your future. This isn't about turning you into an electrician. This is about turning you into a smart, proactive business owner who can spot trouble a mile away and knows exactly who to call. We are going to demystify the world of commercial electricity and give you a clear, actionable playbook. You will learn the subtle, often missed warning signs that your building is sending you right now. You'll understand the massive, non-negotiable differences between the electrician who wired your home and the specialized professional your business legally and practically requires. And you will learn how to make the call for help not when it's too late, but when it's a simple, affordable fix, preventing a catastrophe before it ever has a chance to begin. So let's start with the most important question. Is your building trying to tell you something right now? Electrical problems rarely appear out of nowhere in a giant explosion. They whisper before they shout. They send up smoke signals long before they start a fire. Your job is to learn the language. The first and most common signal is the one people dismiss the most: flickering or dimming lights. You see it, you get annoyed for a second, maybe you tap the light switch and then you forget about it. This is a colossal mistake. In a commercial setting, flickering lights are not a charming quirk. They are a symptom of a serious disease in your electrical system. When lights flicker, especially when a large piece of equipment kicks on, like an HVAC unit, a commercial freezer, or a piece of machinery, it often means the circuit is overloaded. It's like trying to drink a thick milkshake through a tiny coffee straw. The demand for power is too great for the wiring to handle, causing a voltage drop that you see as a dim or a flicker. Why is this so dangerous? Because that overloaded circuit is generating an immense amount of heat inside your walls. The plastic insulation around the copper wire starts to break down, becoming brittle and exposing the live conductor. This is a direct path to an electrical arc, a miniature lightning bolt jumping between wires that can instantly ignite wood, insulation, or drywall. So that flickering light in the break room isn't just an annoyance. It's a potential ignition source for a building fire. It's a sign that your system's capacity is being pushed to its absolute limit. The second whisper is a brother to the first, frequently tripping circuit breakers. Let's be crystal clear about something. A circuit breaker is not a problem. A circuit breaker is a hero. It is a life-saving safety device designed to do one thing: shut off the power when it detects a dangerous condition. When a breaker in your panel trips, it's not failing. It's screaming for help. It's your electrical system's last line of defense. The problem is not the breaker. The problem is why it's tripping. There are two main reasons. The first is an overload, which we just talked about. You have too many things plugged into one circuit, drawing more power than it was designed for. Maybe an employee set up a space heater under their desk, or you added a new high-powered printer without thinking about the load. The second reason is far more sinister. A short circuit. This is when a hot wire touches a neutral or a ground wire. It creates a path of least resistance, causing a massive instantaneous surge of electricity. The breaker trips to prevent that surge from melting the wires and starting a fire. If you have a breaker that you have to reset once a week or once a day, you don't have an inconvenient breaker problem. You have a serious electrical hazard. Continuously resetting it without diagnosing the root cause is like hitting the snooze button on a fire alarm. You're ignoring the warning and allowing a dangerous condition to persist, putting your entire operation at risk. Now for the third sign, and this is one you can feel. Go place your hand carefully on an outlet cover or a light switch plate. Is it warm? Is it hot to the touch? If it is, you have a serious problem that needs immediate attention. Electrical outlets and switches should always be at ambient room temperature. If they feel warm, it means there's a dangerous level of resistance in the connection. This is almost always caused by a loose wire inside the electrical box. As electricity struggles to flow through that loose, weak connection, it generates intense heat. It's like a tiny, uncontrolled electric heater firing up inside your wall. That heat is cooking the plastic of the outlet, making the wires brittle, and creating a perfect environment for a fire. This is not a wait-and-see situation. A warm outlet is an active fire risk. The same goes for any buzzing or crackling sounds you hear from an outlet or switch. That sound is the noise of electricity arcing across a gap that shouldn't be there. It's the sound of a fire trying to start. Finally, and most urgently, is the sign you can smell. If you ever detect a faint fishy smell or the odor of burning plastic and you can't identify the source, you need to consider it an electrical emergency. Many of the plastics and heat-resistant chemicals used in circuit breakers, outlets, and wiring insulation emit a distinct fishy or urine-like odor when they get dangerously hot. It's the smell of your electrical system literally melting. This isn't the time to investigate on your own. This is the time to call a professional immediately, and if the smell is strong, to consider evacuating the area. It's the most urgent whisper of all, the one that comes right before the shout. Flickering lights, tripping breakers, warm outlets, and strange smells. These are not minor annoyances of doing business. They are your building's early warning system. They are clear, undeniable signals that your electrical infrastructure is under stress and failing. Ignoring them is not a calculated risk. It's a gamble with the worst possible odds. You're betting your entire business that it's probably nothing. But as that fire marshal would tell you, it's always nothing until it's everything. So now you know what to look for. You see the signs. You realize that weird flicker in the conference room might be more than just a bad bulb. Your next thought is, I need to call an electrician. And that is where the single most critical decision you will make comes into play. Because the person you call next could either save your business or inadvertently put it in even greater danger. The simple act of Googling electrician near me and hiring the first person who answers could be a catastrophic error. Because the expert who can safely rewire your home's kitchen is, in most cases, completely unqualified to touch the complex, high-powered system in your commercial building. And understanding why is the key to not just fixing the problem, but truly securing the future of your business. So let's talk about a guy named Mark. Mark owned a small, but growing custom woodworking shop in Ohio. He was brilliant at his craft, turning reclaimed lumber into stunning furniture. Business was booming, and he just invested in a brand new industrial-grade CNC machine. A beast that could triple his output. The price tag was steep, but the return on investment was a no-brainer. The machine arrived on a flatbed truck, a gleaming monument to his success. All he needed was to get it wired up. His brother-in-law, Dave, was a residential electrician. A good one, too. Dave had wired Mark's entire house, installed a new panel, and was always reliable. So, to save a few $1,000s, Mark called Dave. Dave came over, looked at the machine specs, and said, "Yeah, no problem. It's just pulling a new line. A bit beefier than a standard outlet, but I can handle it." For 2 weeks, everything was perfect. The CNC machine hummed to life, carving intricate designs with a precision Mark could only dream of. Orders were flying out the door. He felt like he was on top of the world. Then, on a Tuesday afternoon, during a complex cut on a massive oak tabletop, The machine sputtered. The lights in the shop flickered violently. Mark heard a loud pop from the back of the CNC, followed by the sickening smell of burning electronics. The machine went dead. Stone cold dead. Panic set in. He called the manufacturer. They sent a technician who took one look at the electrical connection and shook his head. "This machine runs on three-phase power," the tech said, pointing to the panel. "Your guy wired it for single-phase with a cheap converter. You fried the primary controller and two of the servo motors. You're lucky you didn't start a fire." The repair bill was over $25,000. The lost production time cost him another $10,000. The few $1,000s he saved by calling his brother-in-law ended up costing him nearly $40,000 and two of his biggest clients. Mark's story isn't an isolated incident. It happens every single day in businesses across America, and it all stems from a fundamental misunderstanding of the single biggest difference between your home and your business: the type of power they run on. Your house, my house, nearly every residential building in the United States runs on single-phase power. Think of it like a single cyclist pedaling a bike. You get one push of power for every rotation of the pedal. It's a consistent, reliable wave of electricity. It's perfect for running your lights, your TV, your refrigerator, your microwave. The power delivery has peaks and valleys, but for these smaller loads it's perfectly fine. We don't even notice it. A commercial building, however, is a different animal entirely. It's not a bicycle. It's a high-performance engine. Most commercial and industrial facilities run on three-phase power. Instead of one wave of alternating current, you get three. Imagine now you have three cyclists on that same bike, each positioned a third of the way around the pedal crank. Just as one cyclist's push is starting to wane, the next one is hitting their peak power. Then the third. The result isn't a single wavy power delivery. It's a smooth, constant, and vastly more powerful stream of energy. There are no dips. It's a continuous flow of maximum power. Why is this so important for a business? Because businesses run heavy-duty equipment. Think about the walk-in freezers and massive ovens in a restaurant, the huge HVAC systems cooling a 100,000 square foot office building, the motors running the conveyor belts in a warehouse, the data servers in an IT firm that can never ever shut down, the CNC machine in Mark's workshop. All of this equipment requires that constant, heavy, uninterrupted flow of power to operate efficiently and safely. Trying to run them on single-phase power is like trying to tow a semi-truck with a Prius. You might get it to move a little bit, but you are going to destroy the engine. This is exactly what happened to Mark. His residential electrician, Dave, saw a high-voltage requirement and thought he could just rig a solution. He used something called a phase converter, a device that tries to mimic three-phase power from a single-phase source. But it's an imperfect imitation. It creates an unbalanced load, putting immense strain on the sensitive electronics inside the equipment. The motors in Mark's CNC machine were designed for that smooth three-lane highway of power. Instead, they got a bumpy single-lane country road with a bunch of potholes. They overheated, drew too much current, and eventually the main control board, the machine's brain, sacrificed itself to prevent a full-blown fire. A true commercial electrician would have recognized this in a nanosecond. They wouldn't have even started the job without first verifying the building's service. They live and breathe three-phase power. They understand how to balance the loads across the three phases, ensuring that no single phase is overworked. They know how to properly size the wiring, the conduits, and the breakers specifically for the demands of three-phase motors. It's not just about connecting a red wire and a black wire. It's about orchestrating a complex power system. It's the difference between a local garage band and the New York Philharmonic. Both make music, but the scale, complexity, and skill required are worlds apart. The danger isn't just to your equipment either. An improperly wired three-phase system is a massive safety hazard. Unbalanced loads create immense heat in your electrical panels. They can cause vibrations in motors that lead to premature mechanical failure. They can lead to anti-voltage sags that can corrupt data on your servers or shut down your entire computer network. And in the worst-case scenario, they can lead to arc flashes, explosive electrical events that can cause severe burns, blindness, and even death. This isn't an exaggeration. This is the reality that commercial electricians are trained to prevent. So the first, most crucial question you need to ask is, what kind of power does my business actually need? And what kind does it have? If you're running anything more demanding than a few laptops and a coffee maker, the answer is likely three-phase. And if you have three-phase power, or need it installed, you are unequivocally in commercial electrician territory. Hiring a residential electrician to work on a three-phase system is like asking a dentist to perform heart surgery. They both work on the human body, but you wouldn't trust them with that specific critical task. The devastating cost of equipment replacement and downtime, like Mark experienced, is often just the beginning. The real knockout blow frequently comes from a place most business owners never even consider until it's too late. Because even if the wiring is technically correct, and the power phase is right, there's an invisible web of rules and regulations that can ensnare your business, invalidate your insurance, and leave you facing fines that can cripple your company. This isn't about power, it's about permission. And navigating that labyrinth is the second great divide that separates the pros from the pretenders. Think of every rule in the National Electrical Code, the NEC, as a tombstone, a lesson written in ash and paid for in lives. That requirement for arc fault protection? That's for the family who lost everything to a fire started by a frayed wire inside a wall. That specific grounding requirement for industrial equipment? That's for the machinist who was electrocuted by a machine that looked perfectly fine. This isn't just a book of suggestions. It's the collected wisdom of every electrical disaster in modern history. A fortress of regulations designed to keep the chaos of high-energy physics safely contained. And your local city and state codes? They take that fortress and add their own moats and drawbridges, specific to your region's climate, building materials, and power grid. A commercial electrician doesn't just read this book. They are fluent in its language. They understand that the code for a restaurant kitchen, with its high heat, high moisture environment, is fundamentally different from the code for a data center, where static discharge and clean power are paramount. They know the exact type of conduit required to be run underground versus inside a fire-rated wall. They know the precise load calculation needed to prove to a skeptical city inspector that your new bank of servers won't plunge the entire office park into darkness. This knowledge is the key that unlocks the first gate in the labyrinth: the permit. For a business owner, a building permit can feel like a bureaucratic nightmare, a frustrating delay designed to cost you time and money. For a commercial electrician, it's step one. It's the flight plan filed before takeoff. Attempting to do any significant electrical work in a commercial setting without a permit isn't just cutting a corner. It's like trying to perform surgery using a diagram you drew on a napkin. When a commercial electrician files for a permit, they aren't just filling out a form. They are submitting a detailed battle plan. This includes architectural-grade blueprints, schematics showing every circuit, every junction box, every connection. It includes meticulous load calculations that prove the existing infrastructure can handle the new demand, or it details the necessary upgrades. This package of documents is a legal declaration. It's the electrician putting their license, their insurance, and their entire professional reputation on the line, stating, "I have designed a system that is safe, efficient, and compliant with every applicable code." This plan then goes to a city engineer for review. This is someone whose entire job is to find the one mistake, the one oversight, the one tiny flaw in the plan that could lead to catastrophe. They are the ultimate skeptic. They will question everything. And they will instantly reject a plan submitted by someone who doesn't speak their language. The back and forth, the requests for clarification, the need to cite specific code sections. This is a conversation that can only happen between two seasoned professionals. If the plan is approved, the permit is issued. But that's not the end. It's the beginning of the next trial, the inspection. Once the work is done, but before the walls are closed up and the evidence is hidden, the inspector arrives. This is the moment of truth. They don't care how nice the new light fixtures look. They arrive with a flashlight, a keen eye, and a deep knowledge of every shortcut an amateur might try to take. They're looking at the gauge of the wire to make sure it matches the breaker. They're checking the staple placement inside the studs. They're verifying the torque on the terminal screws inside the panel. They are physically testing the grounding and bonding to ensure a fault will go safely to the earth, not through one of your employees. A past inspection is more than just a sticker on a panel. It is a legal third-party certification that the work was done correctly and safely. It's the document your insurance company will demand to see after a fire. It's the proof that you, the business owner, practice due diligence in protecting your property and your people. Let me tell you about a business owner. Let's call him David. David owned a growing craft brewery. He bought a new, larger fermentation tank that required a powerful three-phase electrical hookup. The quote from a licensed commercial electrical contractor was steep, and a big chunk of it was listed for permitting, engineering, and inspection. A guy who frequented the brewery, a so-called jack of all trades, told David he could do it for half the price, cash, over the weekend. No permits, no inspectors, no hassle. David, trying to be smart with his capital, took the deal. The handyman ran the new line, hooked up the tank, and by Monday morning it was humming away. David felt like a genius. He'd saved $10,000. For 6 months everything was perfect. His production increased and business boomed. Then one Thursday night an employee was cleaning up, hosing down the concrete floor. A small, unnoticeable leak had developed in a coolant line on the new tank, creating a puddle. The handyman, to save a few bucks, hadn't used the proper watertight conduit and fittings required for a wet environment. He also hadn't properly bonded the metal frame of the tank to the building's grounding system. When the employee's stream of water hit the improperly sealed junction box, the entire metal chassis of the massive steel tank became energized with 240 volts of electricity. The puddle on the floor completed the circuit. The employee was killed instantly. The aftermath was an absolute demolition of David's life and business. The investigation was immediate. The fire marshal took one look at the new wiring and asked for the permit. There wasn't one. He looked at the electrical panel and saw a new unlabeled breaker. Red flag. He examined the work itself and listed over a dozen flagrant code violations in his report. David's insurance claim was denied in a single phone call. The policy had a clear clause invalidating coverage for damages or liability arising from unpermitted, non-compliant work. He was sued by the employee's family for wrongful death, a suit he had no defense against. The Occupational Safety and Health Administration, or OSHA, hit him with fines so massive they made his eyes water. And the city levied its own penalties for the unpermitted work, then red-tagged his entire facility, shutting down his operation indefinitely until every inch of wiring was brought up to code by a licensed contractor, the very thing he tried to avoid in the first place. David didn't save $10,000. He paid $1 million price, in money, in reputation, and in a human life, for a lesson a commercial electrician learns on day one. The permit and inspection process isn't the obstacle to getting the work done. The permit and inspection process is the work. It's the public, legal, and moral verification that you are not putting your business, your neighbors, and your team at risk. It's the dividing line between a professional installation and a ticking time bomb. But even with the right knowledge and the official permits, you can't win this war with the wrong weapons. The very materials a commercial electrician uses are a language in themselves, a specialized arsenal designed for a battlefield you've never even seen. And that is the third great divide. Let's open up that arsenal. Let's look inside the toolbox of a commercial electrician and see why the gear they carry is fundamentally different from what you'd find at your local home improvement store for a weekend project. This isn't about brand names or fancy gadgets. This is about a fundamental difference in the physics of power and the demands of a commercial environment. In your home, the electrical wires running through your walls are likely bundled together inside a flexible plastic sheathing. It's a cable commonly known by the brand name Romex. It's safe, efficient, and perfect for the controlled, low-impact environment of a residential home with wooden studs. But using that same cable in a commercial building? That's like sending a soldier into a firefight wearing a t-shirt and jeans. It's completely inadequate for the battlefield. Commercial environments demand armor. And for electrical wiring, that armor is called conduit. Conduit is the rigid or flexible tubing, usually made of metal or high-strength plastic, that houses and protects the electrical wires. It's a non-negotiable requirement in almost every commercial setting in the United States. Why? Because the risks are exponentially higher. Your business has more people, more foot traffic, more machinery, more vibrations, and a much higher risk of physical impact. The walls are often made of metal studs, which can chafe and cut into unprotected wires over time, creating a hidden fire hazard. Conduit acts as a shield, a protective raceway that guards the delicate conductors inside from being crushed, cut, or corroded. It also makes it far easier and safer to pull new wires or replace old ones in the future without having to tear open walls. You're not just running a wire. You're building an electrical highway system designed for durability and future access. And just like there are different vehicles for different roads, there are different types of conduit for different commercial applications. There's EMT, or electrical metallic tubing, a lightweight steel conduit that's the workhorse for most indoor commercial spaces. Then you have rigid metal conduit, or RMC. This is the tank. It has thick, heavy-duty walls and is used in places where there's a serious risk of physical damage, like in a machine shop, a warehouse forklift aisle, or outdoors where it's exposed to the elements. There's PVC conduit for underground runs, or in corrosive environments where metal would rust away. Each type is a specific tool for a specific job, chosen by a professional who understands the unique threats present in your business. A residential electrician might spend their entire career barely touching rigid metal conduit, while a commercial electrician bends and installs it every single day. Now, what about the wires that run inside this armor? Again, it's a completely different world. Instead of the pre-packaged, all-in-one Romex cable, commercial conduit contains individual, insulated wires called conductors. Typically, you'll see wires with designations like THN or THWN. This matters for a very important reason: heat. A bundle of wires wrapped in a plastic jacket, like Romex, traps heat. Individual wires running through the air-filled space inside a conduit can dissipate heat much more effectively. And in business, you are generating a lot more heat. Think about the electrical load. Your home might have a few computers, a TV, and a refrigerator. Your office has dozens of computers, servers, printers, and network equipment running 24/7. Your restaurant has commercial ovens, walk-in freezers, and industrial dishwashers, all drawing massive amounts of power simultaneously. This constant, heavy load generates significant heat in the wires. Using residential-grade wiring in this scenario is like trying to put out a 5-alarm fire with a garden hose. The wires will overheat, the insulation will degrade and become brittle, and eventually, it will fail, creating a catastrophic short circuit and a very real risk of fire. Commercial-grade conductors are designed specifically for this high heat, high-load environment, ensuring the lifelines of your business don't melt under pressure. But the materials themselves are only part of the story. The very nature of the power they carry is different. This is where we get to the heart of the commercial electrical system: the panel board and the type of power it supplies. Your home almost certainly runs on 120/240-volt single-phase power. It's simple, effective, and all you need to power your lights and appliances. Think of single-phase power as one person pedaling a bicycle. It provides power in a single alternating wave. It gets the job done, but it has its limits. Most commercial buildings in the USA, on the other hand, are powered by three-phase power. Instead of one wave of power, you get 3 distinct waves delivered in perfect sequence. Now, imagine 3 people pedaling that same bicycle, each pushing down on a pedal at a different, perfectly timed interval. The power delivery is incredibly smooth, consistent, and vastly more powerful and efficient. This is essential for running large motors found in HVAC systems, elevators, industrial machinery, or commercial kitchen equipment. Trying to run a 3-phase motor on single-phase power is physically impossible without expensive converters, and it would be incredibly inefficient. A commercial electrician lives and breathes in the world of 3-phase power. They understand how to balance the loads across the 3 phases to ensure the system runs efficiently and safely, preventing overloads on any single phase that could damage your expensive equipment. This difference in power type brings with it different voltages. While you might see the familiar 120 volts for standard outlets, commercial buildings often use a 120/208 volt system, or even more commonly, a 277/480 volt system. Why the higher voltage? It's all about efficiency. Pushing more power through a wire at a lower voltage requires a much thicker, more expensive copper wire. By increasing the voltage, you can deliver the same amount of power with smaller, more cost-effective wires. That 277-volt circuit? That's what's likely powering the thousands of square feet of high-efficiency fluorescent or LED lighting in your office or warehouse. That 480-volt 3-phase circuit? That's the beast that's powering the massive air conditioning unit on the roof that keeps your entire building cool in July. Or the conveyor belt system that is the backbone of your entire production line. These high voltages are incredibly dangerous. They are unforgiving. A mistake with 120 volts can hurt you badly. A mistake with 480 volts can be instantly fatal and can create an arc flash, an explosive electrical blast with the force of dynamite and the temperature of the sun's surface. This is not a realm for amateurs or handymen. The panel boards that manage this power are also built to a much higher standard. Instead of the simple snap-in breakers you see in a residential panel, commercial panel boards often use bolt-on breakers. They are physically bolted onto the metal bus bars inside the panel, creating a much more secure and reliable connection that can withstand the vibrations and heavy loads of a commercial environment, significantly reducing the risk of a loose connection, which is a primary cause of electrical fires. So you see, it's not just about bigger wires or metal pipes. It's a completely different philosophy of power distribution, built for a world of relentless demand, higher risk, and zero tolerance for failure. These materials aren't just heavy duty. They are the physical embodiment of a different set of rules, a different understanding of risk and reliability. Choosing the wrong material isn't just a code violation. It's a direct threat to your property, your employees, and the very continuity of your business. But having the right weapons is only half the battle. You need a soldier who knows how to use them, a strategist who understands the terrain. And that brings us to the fourth and perhaps most critical divide of all. The divide between playing defense and playing offense. The chasm between reacting to disaster and architecting for success. This is the difference between the business owner who sees an electrician as a firefighter and the one who sees them as a strategic partner. Let's call the first one Dave. Dave runs a successful downtown restaurant. It's his passion, his life's work. The kitchen is a symphony of controlled chaos, the dining room a buzz of happy customers. To Dave, electricity is like the air he breathes. He only notices it when it's gone. His philosophy is simple. If it ain't broke, don't fix it. One Tuesday, a circuit breaker for the prep station trips. Annoying but not a crisis. He walks to the back, flips it and forgets about it. On Thursday it happens again. This time he grumbles about the new blender his chef bought. On Friday night, at the absolute peak of the dinner rush, the entire kitchen goes dark. Not just the prep station, the walk-in cooler, the dish pit, the main oven. The symphony grinds to a screeching halt. Panic sets in. The air, once filled with the savory aroma of searing steaks, now hangs thick with the metallic scent of fear and the rising odor of food starting to warm in a dead cooler. Dave fumbles for his phone, frantically Googling, 24/7 electrician near me. He calls the first number that pops up. The voice on the other end promises to be there in an hour, but the emergency call-out fee he quotes makes Dave's stomach clench. An hour later, a guy shows up in a van that looks more suited for residential jobs. He pokes around the panel, muttering about how overloaded it is, how it was never designed for this much commercial equipment. He manages to get the lights back on with a temporary and frankly terrifying-looking bypass, but he tells Dave the whole panel needs a major, expensive upgrade. The damage is done. The Friday night rush is a total loss. Thousands of dollars in food in the walk-in cooler has to be thrown out. Angry one-star reviews start popping up online from customers with canceled reservations. Dave got his power back, but he paid for it not just with an exorbitant emergency fee, but with lost revenue, spoiled inventory, and a stain on his hard-earned reputation. Dave was a firefighter. He waited for the blaze and then paid any price to put it out. Now let's meet Sarah. Sarah owns a small but growing manufacturing plant on the other side of town. She makes high-precision components for the aerospace industry. For her, downtime isn't an annoyance. It's a catastrophic failure that can violate contracts worth hundreds of thousands of dollars. When Sarah first acquired her facility, before she even moved in a single piece of multi-million-dollar CNC machinery, she made a call. Not to an emergency hotline, but to a highly rated commercial electrical contractor. She didn't have a problem. She was paying to find problems she didn't know she had. She hired them for a complete electrical system audit. They didn't just check the outlets. They used thermal imaging cameras to scan her electrical panels, looking for hot spots, connections that were dangerously overheating under load, invisible to the naked eye. They analyzed the building's power consumption, the age of the transformers, and the capacity of the main service. They found that the lighting was an ancient, energy-guzzling system costing her a fortune every month. They discovered that the main panel, while functional, had zero room for the new machinery she planned to add in the next fiscal year. These weren't fires. They were blueprints of future fires. Working with the contractor, Sarah became an architect of her own resilience. They scheduled a complete panel upgrade over a planned holiday weekend, ensuring zero operational downtime. They developed a phased plan to retrofit the entire facility with high-efficiency LED lighting. The energy savings from that one move alone would pay for the entire electrical audit within 18 months. And most importantly, she put them on a quarterly preventative maintenance contract. Every 3 months, they come in to retort connections, clean components, and run diagnostics. A year later, a brutal summer heat wave descends on the city. The power grid is strained to its breaking point. Businesses all over town start experiencing brownouts and failures. Dave's restaurant, with its patched-up, overloaded system, goes dark again. But Sarah's facility? It hums along without a single flicker. Her climate control is stable, her precision machines are running within their tight tolerances, and her production schedule is uninterrupted. While her competitors are dealing with fried equipment and sending workers home, Sarah is calling their clients and taking on the orders they can no longer fill. Her decision to be proactive didn't just prevent a disaster. It became a powerful competitive advantage. This is the fundamental divide. It's not about residential versus commercial. It's about a mindset. Are you paying to get out of trouble, or are you investing to stay out of trouble? A reactive business owner sees a commercial electrician as an expense, a necessary evil. A proactive owner sees them as a partner, a consultant who manages risk and unlocks potential. So what does being an architect like Sarah actually look like in practice? It starts with that comprehensive electrical audit. This is the foundation. It's a top-to-bottom analysis of your entire system, identifying vulnerabilities, code violations, and inefficiencies. It's like a full-body physical for your building, giving you a baseline of health from which you can make intelligent decisions. Next is creating a preventative maintenance program. This is not a janitor changing a light bulb. This is scheduled, high-level technical work. It involves a discipline called thermography, using those infrared cameras to see heat building up in your system, the #1 precursor to electrical fires and equipment failure. It means checking and tightening every single mechanical connection in your panels, because believe it or not, thermal expansion and contraction can cause them to loosen over time, creating a dangerous arc fault situation. It's about keeping your system clean, calibrated, and operating at peak efficiency. And finally, it's about strategic planning and future-proofing. Your business isn't static, and your electrical system shouldn't be either. A true commercial electrical partner doesn't just fix what's broken. They ask where you're going. Are you adding a new wing to your building in 2 years? Are you planning to install a fleet of electric vehicle chargers for your company cars? Are you considering solar panels or a backup generator to become more resilient? A proactive electrician helps you design the electrical infrastructure for the business you're going to be tomorrow, not just the one you are today. They ensure that when it's time to grow, you can just plug in and go, instead of having to tear everything down and start over. The objection is always the same. This sounds expensive, but that's the firefighter's mindset talking. Let's reframe the question. What is the true cost of an emergency? It's the $100 an hour planned maintenance versus the $400 an hour emergency call-out fee at 2 a.m. It's the cost of a new $50 breaker versus the cost of a $50,000 piece of machinery it was supposed to protect. It's the cost of a maintenance plan versus the cost of a single day of lost revenue, angry clients, and a damaged reputation. You change the oil in your fleet vehicles. You service the HVAC system. You patch the roof before it leaks. You don't wait for your critical assets to catastrophically fail before you pay attention to them. The electrical system is not just another asset. It is the central nervous system of your entire operation. Treating it with a reactive, if it ain't broke mentality is one of the single greatest gambles a business owner can make. Shifting your mindset from firefighter to architect is the most important step you can take. But once you've made that shift, a new set of questions emerges. How do you spot the subtle signs of trouble before they become a 5-alarm fire? What are the quiet whispers from your building that warn of a screaming failure on the horizon? Because the flickering lights in the conference room might not just be a bad bulb. They could be the first tremor before the earthquake. Let's start with those flickering lights. It's so common, we've almost been conditioned to ignore it. We see it in movies to signal a haunted house, but in your business, it's signaling a very real-world horror story. You think, oh, it's just a fluorescent ballast going bad. Or, this bulb is on its last legs. And maybe it is. But what if it isn't? What if that flicker is a symptom of a system under severe stress? Imagine the electrical wiring in your walls is like the vascular system in a human body. Constant, steady flow is healthy. But a flicker? That's a microstroke. It's a sign that somewhere, a connection is failing. A wire is loose. A circuit is so overloaded that it's gasping for air every time a heavy piece of equipment kicks on. Think about it. The lights in your office dim for a second when the big HVAC unit on the roof starts up. You barely notice. But what's actually happening is that the HVAC is demanding such a huge gulp of power that it's momentarily starving everything else on that circuit. It's a power brownout, contained within your own building. Over time, that constant strain, that yanking and pulling of voltage degrades connections. It heats up wires. It weakens the entire system, making it brittle. That little flicker is the tremor. The earthquake is when that stressed, weakened connection finally fails, arcs, and ignites the material around it. It's a fire that starts not with a bang, but with a barely noticeable dip in the lights you've been ignoring for 6 months. Then there's the circuit breaker. We've come to see it as a magic reset button. The power goes out in the back office, you walk to the panel, see the one switch that's out of line, and you just flip it back. Problem solved, right? Wrong. Absolutely fundamentally wrong. A circuit breaker tripping is not the problem. It is a desperate, last-ditch safety measure. It's your building's head of security screaming, "There's an intruder. Shut everything down." And what do? You walk over, tell him to relax, and open all the doors again. When a breaker trips repeatedly, it's telling you one of two things, and both are bad. The first is a simple overload. You have too much stuff plugged into one circuit. That laser printer, the marketing team's 2 extra monitors, the mini fridge, the space heater under Sarah's desk in the winter. The breaker is doing its job, preventing the wires in the wall from overheating and melting. By constantly resetting it, you're essentially telling the system, "I know you can't handle this, but do it anyway." You are willfully forcing the system past its breaking point. Every time you do that, you're cooking the insulation on those wires just a little bit more, bringing them one step closer to failure. But the second reason is far more sinister. A short circuit. This isn't just too much stuff. This is raw electrical current going where it shouldn't. A wire's insulation has been chewed by a rodent. A loose connection is causing 2 wires to touch. This is a direct 5-alarm fire hazard right now. The breaker trips to stop it. If you force it back on, you could be giving that fire the green light. A commercial electrician doesn't just flip the breaker back on. They diagnose why it tripped. They use testers to determine if it's an overload, which requires a new circuit, or a short, which requires finding and repairing a dangerous fault. Ignoring a tripping breaker is like finding a puddle of water on your floor and just putting a wet floor sign next to it instead of finding the burst pipe. The damage is still happening, you're just not acknowledging it. Let's talk about the ghosts in the machine, the things you hear and smell. Have you ever been near an outlet or a light switch and heard a faint buzzing or crackling sound? That is not normal. That is the sound of electricity arcing. It's the sound of power literally jumping across a gap it's not supposed to cross, like a lightning storm happening inside your wall. This generates intense heat, well over 1,000 degrees Fahrenheit, in a tiny concentrated spot. It will melt plastic, char wood, and ignite dust and insulation. That buzzing sound is the literal sound of a fire starting in slow motion. And the smell? It's often a faint, sharp, fishy, or acrid plastic smell. You can't quite place it. You think maybe it's the trash or something someone microwaved in the break room. But often, it's the smell of a wire's PVC insulation overheating and off-gassing. It's the smell of a component in your breaker panel, an outlet, or a switch slowly burning itself to death. Your nose is one of the most sensitive safety instruments you have. If something smells hot, or like burning plastic, and you can't immediately identify the source, you have an electrical emergency. It's not a call tomorrow situation. It's a call a 24/7 commercial electrician right now situation. A business owner in Phoenix told me his staff kept smelling something weird in their server room for a week. They blamed a new air freshener. It was actually the main power feed to their server rack slowly melting inside the conduit. They were minutes away from an event that would have destroyed their entire company's data and infrastructure. They got lucky. Luck is not a business strategy. Finally, let's talk about the things you can physically feel. Go walk over to an outlet where a hydro appliance is plugged in, a copy machine, a large refrigerator, a portable AC unit. Put your hand on the faceplate. It should be cool to the touch. If that outlet plate is warm or even hot, you have a serious problem. Heat is the enemy of every electrical system. It's a sign of resistance. It means the connection between the plug and the outlet is poor, or the wiring to the outlet is failing. That heat isn't just contained to the plate. It's traveling down the wires into your wall. And what about the plugs themselves? Do you have any outlets that won't hold a cord tightly? Where the plug just sags and falls out? That's not just an annoyance. The metal contacts inside that outlet are worn out. They aren't gripping the prongs of the plug tightly, creating a loose, high-resistance connection. This is a classic recipe for arc faults and fires. For the $2 it costs to replace that outlet, you are risking thousands in damages. The same goes for light switches. If a switch is hot to the touch, or if it makes a crackling sound or feels mushy when you use it, it's failing internally. It needs to be replaced. These small, seemingly insignificant details, a flicker, a trip, a buzz, a warm to the touch outlet, are the vital signs of your building's electrical health. They are the clear, unambiguous signals that it's time to call in a professional before the whispers become a scream. So let's talk about Frank. Frank owned a bustling downtown bistro, the kind of place where the lunch rush was a symphony of clattering plates and happy chatter. For weeks, he'd noticed the lights in the kitchen would dim for just a second whenever the big industrial dishwasher kicked on. He'd also noticed the circuit breaker for the main refrigeration line had tripped twice in 1 month. He told himself it was an old building. He told himself he was too busy. He told himself a service call was an expense he'd get to later. Later arrived on a Friday night at 7:30 p.m., with a full house and a line out the door. It didn't arrive as a flicker or a buzz. It arrived as a loud, violent pop from the main electrical panel, followed by the smell of ozone and melting plastic. The lights didn't just flicker, they died. The refrigerators, the ovens, the point-of-sale system, everything went silent. The scream had arrived. Frank's profitable Friday night turned into a chaotic evacuation. The cost wasn't a $200 service call. It was thousands in lost revenue, a cooler full of spoiled food, an emergency call-out that cost 10 times the normal rate, and a week of forced closure to rewire a panel that had catastrophically failed. Frank's story isn't an outlier. It's the inevitable conclusion for thousands of business owners who fall victim to what I call the procrastination penalty. It's the dangerous belief that small electrical problems are like a leaky faucet, annoying but manageable. But your electrical system isn't plumbing. It's the central nervous system of your entire operation. Ignoring its warning signs isn't saving money. It's gambling with everything you've built, and the house always wins. The key is to shift your mindset from reactive to proactive. You have to know the specific, non-negotiable triggers that mean you stop what you're doing and pick up the phone. This isn't about paranoia. It's about strategic risk management. So let's build that list. Let's talk about the absolute drop-everything moments when a commercial electrician is not a luxury, but an immediate necessity. First, and this is a massive one for growing businesses, you're installing new heavy-duty equipment. Maybe you're a print shop upgrading to a faster, larger press. Maybe you're a workshop adding a new CNC machine, or a restaurant getting a new walk-in freezer. You cannot, I repeat, cannot just plug it in and hope for the best. That new machine has a specific power requirement, a load. Your building's electrical panel has a maximum capacity. Pushing a new, heavy load onto an existing circuit that was only designed for lighting and a few outlets is like trying to drive a semi-truck over a rickety wooden footbridge. It might hold for a minute, but a collapse is inevitable. A commercial electrician doesn't just run a new wire. They perform a load calculation. They assess the total power draw of your entire facility, look at the capacity of your main service, and determine if your system can handle the new addition. They'll ensure the new equipment gets its own dedicated circuit, with the correct gauge of wire and the properly rated breaker, to protect both your multi-thousand-dollar investment and the rest of your building. Trying to save a few $100s here is the fastest way to turn your shiny new machine into a very expensive, very quiet piece of modern art. Second on the immediate call list, any unusual smells, especially a burning smell. This sounds obvious, but you'd be shocked how many people rationalize it. Oh, it's probably just dust on a heater. Or maybe it's the new air freshener. Let me be clear. An electrical burning smell is uniquely acrid and plastic-like. It's the smell of wire insulation or PVC, overheating and breaking down. This is the smell of an active, ongoing fire hazard. It could be a loose connection in an outlet arcing and generating immense heat. It could be a component inside your breaker panel failing and literally melting down. It could be an overloaded wire inside a wall starting to cook. There is no such thing as a minor electrical burning smell. It is the final desperate warning your system can give you before ignition. When you smell this, you don't finish your email. You don't wait until lunch. You shut down the power to the affected area if you can do so safely, and you call an electrician. Period. It's a 5-alarm fire for your senses, and you need to treat it that way. Third, frequent and recurring circuit breaker trips. A circuit breaker that trips once in a blue moon when you plug in too many things is doing its job. It's a safety device. But a breaker that trips repeatedly, daily or even weekly, is not a nuisance. It is a critical diagnostic message. It's telling you one of two things, both of them bad. Either the circuit is persistently overloaded, meaning you're consistently demanding more power than the wire is rated to handle, which generates dangerous heat. Or, far more sinisterly, you have an intermittent short circuit somewhere along the line. This could be a frayed wire, a damaged outlet, or a faulty piece of equipment creating a dangerous path for the electricity. Think of that breaker as a guardian angel. The first time it trips, it saved you. But if you keep forcing it to save you over and over again by just flipping it back on without addressing the root cause, eventually it's going to fail. And when a breaker fails to trip, the circuit stays live, the wires get hotter and hotter, and that's how walls catch fire. A recurring trip is your building screaming for a doctor. Fourth, and this is crucial for any business that ever plans to change its layout, renovations and code compliance. In the United States, all electrical work is governed by the National Electrical Code, or NEC, as well as a host of state and local codes that are often even stricter. These codes are not suggestions. They are the law, written from a century of experience with fires, accidents, and electrocutions. When you decide to move a wall, add an office, or reconfigure your retail space, you are almost certainly going to impact the electrical system. Hiring a handyman or trying to DIY this work is one of the most short-sighted decisions a business owner can make. A licensed commercial electrician understands the code. They know the requirements for outlet spacing, the type of conduit needed in a commercial space, the rules for running data cables alongside power lines, and the specific demands for emergency lighting and exit signs. Getting this wrong doesn't just create a safety hazard, it guarantees you will fail your next building inspection. This can lead to fines, forced closures, and in order to rip out all the non-compliant work and have it redone by a professional, costing you double. Before you move a single wall, you call an electrician to plan the electrical relocation and ensure every single new wire and box is 100% up to code. Let's put this in the starkest terms possible. The cost of a diagnostic visit from a qualified commercial electrician might be a few $100s. The cost of waiting? Let's tally it up. For Frank, it was $10,000 in spoiled inventory and lost revenue for the week, plus another $5,000 for the emergency repair and panel replacement. For a small manufacturing shop that ignores an overloaded circuit, a fire could mean $250,000 in equipment damage and months of lost production. For an office building with faulty wiring that fails an inspection, it could mean fines and project delays costing tens of thousands. The math is brutal and it is undefeated. The small, proactive investment in professional expertise is infinitesimally smaller than the catastrophic, reactive cost of a failure. Those whispers, the flicker, the trip, the buzz, are your opportunity to solve a problem for the price of a service call. Ignoring them until they become a scream means you'll be solving that same problem for the price of a disaster. So now you recognize the signs. You understand the stakes. You can see the flickering light in your own break room not as an annoyance, but as a clear blinking signal that action is required. You know without a doubt that you need to make the call. But who exactly are you calling? In a world filled with contractors, how do you find the right one? How do you distinguish the true professional who can safeguard your business from the cut-rate operator who might just make things worse? The safety of your business, your employees, and your investment doesn't just depend on when you call, but who you call. And the questions you ask before they ever open their toolbox are the most important questions you'll ask all year. So let's break down that vetting process. This isn't just a checklist, it's a shield. Each question is a layer of armor protecting you from catastrophic failure, financial ruin, and the kind of liability that can sink a company overnight. Hiring a commercial electrician isn't like finding a handyman on a local app. The stakes are 1,000 times higher. The first question is the gatekeeper, the absolute non-negotiable baseline. Are you licensed and insured for commercial work in this state and city? And you don't just take their word for it. You ask for the license number and the certificate of insurance. Let's be crystal clear about why. A license isn't just a piece of paper. It's proof that they have passed rigorous testing on the National Electrical Code, or NEC, the Bible of electrical safety in the United States. It proves they understand the physics of power, the theory behind circuitry, and the legal standards they are bound to uphold. A residential license is not a commercial license. The power loads, the three-phase systems, the conduit requirements, it's a completely different world. Hiring an electrician with the wrong type of license is like hiring a pilot who's only ever flown a Cessna to captain a 747. Then there's insurance. They need two kinds, minimum: general liability and workers' compensation. General liability protects you if their work accidentally causes damage to your property. Imagine they're working in your ceiling, they drill into a water pipe, and it floods your server room. Without their liability insurance, that multi-thousand-dollar disaster lands on your desk. Workers' compensation is even more critical. If one of their employees gets shocked, falls off a ladder, or is injured in any way on your property, their workers' comp covers it. If they don't have it, you, the business owner, can be held liable for their medical bills and lost wages. Suddenly, you're not just paying for an electrical repair. You're paying for someone's long-term disability. Ask for that certificate of insurance and check that it's current. No certificate, no conversation. It's that simple. Once you've cleared that hurdle, the next question gets more specific. What is your experience with businesses like mine? This is where you separate the generalists from the specialists. An electrician is a broad term. You need a commercial electrician who lives and breathes your industry. The electrical needs of a restaurant with its high-draw ovens, walk-in freezers, and specialty lighting are vastly different from a medical clinic with sensitive diagnostic equipment that requires isolated ground circuits. A data center needs an expert in uninterruptible power supplies and redundant systems. A manufacturing facility needs someone who understands motor control centers and high-voltage machinery. Ask them, have you worked in a facility like this before? Can you talk about a project you completed for a similar business? If their portfolio is all new home construction and kitchen remodels, they are not the right fit for your commercial enterprise, no matter how good their price is. You are paying for their expertise, not just their tools. This leads directly to the third question, the one that proves their claims. Can you provide me with references from the last 3 commercial jobs you completed? And don't just accept a list of names. Call them. Ask the other business owners. Was the project completed on time? Was it on budget? How did they handle unexpected problems? Were they clean, professional, and respectful of the business operations? Were there any issues after they left? This is your due diligence. A reputable contractor will be proud to share their references. An electrician who hesitates, who says their client's information is private, or who gets defensive, is waving a giant red flag. They're either new to the game, or they're hiding a trail of unhappy customers. You need to find out which it is before they're cutting into your walls. Fourth, you must ask about the invisible framework that governs all their work. How do you handle permits and inspections? The answer to this question will tell you everything you need to know about their professionalism and integrity. The correct answer is, we handle the entire process. We determine which permits are required by the local authority, we file all the necessary paperwork, we schedule the inspections with the city or county inspector, and we ensure the work passes. Any other answer is a deal breaker. If an electrician says, "Oh, you don't need a permit for a job this small," or worse, "We can save you some money if we do it without a permit," you end the conversation and show them the door. Working without a permit is illegal. It means if anything goes wrong, your business insurance can deny your claim. It means when you go to sell the building, an inspector will find the unpermitted work, and you'll have to pay to tear it all out and have it redone correctly. That money-saving shortcut just became a 5-figure nightmare. A true professional never cuts corners on code or legal requirements. Their job is to protect you from those risks, not expose you to them. Fifth, you need to look them in the eye and ask a question about their culture. What are your safety protocols? This isn't about checking a box. It's about understanding their commitment to a safe work environment, which directly impacts the safety of your employees and your property. Ask them about their safety record. Do they conduct regular safety training? What is their policy on personal protective equipment, or PPE? A professional crew will show up with hard hats, safety glasses, and proper footwear without exception. Ask them to explain their lockout/tagout procedure. This is a critical safety step where they de-energize a circuit and physically lock the breaker to ensure no one can accidentally turn the power back on while they're working. If they can't clearly and confidently explain their lockout/tagout process, they are a danger to themselves and to your business. A company with a strong safety culture isn't just following rules. They're actively preventing disasters. Finally, we get to the money, but it's about more than just the final number. The last crucial question is, can you provide a detailed, itemized quote and explain your warranty? A one-line estimate on the back of a business card that just says electrical work, $5,000, is unacceptable. You need a professional proposal that breaks everything down. The cost of materials like wire, conduit, breakers, and fixtures, the hourly rate for labor and the estimated number of hours, the fees for permits, and any other associated costs. This protects you from scope creep and surprise charges. It creates a clear set of expectations for both parties. And what about after the job is done? Ask about their warranty. A confident, professional electrician will stand behind their work. They should offer a warranty on their workmanship, typically for at least a year, and they should pass along the manufacturer's warranty for any parts they install. This is your assurance that if a connection fails or a breaker they installed is faulty, they will come back and make it right without charging you again. By asking these 6 questions, you've done more than just hire an electrician. You've hired a partner. You've weeded out the amateurs, the corner cutters, and the uninsured liabilities. You've chosen a professional who values safety, understands your specific needs, respects the law, and stands behind their work. You've built a foundation of trust before a single wire has been pulled. So you've asked the right questions, you've checked the references, and you've found your pro. You've dodged the bullet that took down countless other businesses. But the danger isn't over. Now the work begins. And how you manage that project from the first day on site to the final inspection is the final firewall protecting your business from a 6-figure mistake. The initial quote is just the beginning. The contract is signed, the deposit is paid, and the electrician's van is scheduled to arrive on Monday. For most business owners, this feels like the finish line. In reality, it's the starting gun for the most critical and often chaotic phase of the entire process. This is where a project succeeds or spirals into a nightmare of delays and cost overruns. It all begins with a single meeting that most people treat as a formality, the pre-construction meeting. Do not skip this. Do not treat it lightly. This is your opportunity to set the ground rules and establish a framework of accountability. In that room should be you, your primary point of contact, the electrician's project manager, and the lead foreman who will actually be on site. Your first order of business is to review the scope of work, line by line, one last time. You'll say, just so we are all on the exact same page, we are running 3 dedicated 20-amp circuits to the kitchen prep area. The new LED grid is going in the main showroom, and the sub-panel is being installed in the west wing. Is that correct? You want verbal confirmation from their entire team. This eliminates any, "I thought you meant" excuses later. Next, communication. This is non-negotiable. Who is your single point of contact? Not a generic office number. You need the cell phone number of the project manager. How will updates be delivered? Don't accept vague promises. Demand a daily end-of-day email or text with a simple summary. Today we completed rough-in on the north wall. Tomorrow we start pulling wire for the server room. No issues. And you want a more formal weekly progress report that tracks the work against the schedule. Speaking of the schedule, you need to dissect it. The finish date is not the schedule. The schedule is the series of milestones that lead to that date. When will the rough-in be done? When is the inspection scheduled? When will the fixtures be installed? And crucially, you need to ask about materials. Have all the major components, the panel board, the breakers, the light fixtures been ordered? What are the lead times? Do you have them in your possession? In today's world of supply chain chaos, a 6-week delay on a critical piece of switchgear can derail your entire grand opening. A professional contractor will have already factored this in. A less prepared one will be figuring it out on the fly, on your dime and on your time. This meeting sets the tone. It shows you are an engaged, professional client who expects a high level of organization. It makes them better. But no amount of planning can prepare you for every possibility lurking behind your walls. And that brings us to the most feared phrase in any construction project, the change order. A change order is a formal amendment to the contract, changing the scope, the price, or the timeline. Sometimes they are absolutely necessary. Let's say you're renovating a 100-year-old building for your new coffee shop. The electrician opens up a wall to run a new circuit and finds ancient, brittle, cloth-covered wiring. A massive fire hazard that wasn't visible before. He can't, in good conscience or by code, just cover that back up. That requires a change order to rewire the entire section. It's an unforeseen condition, and it's a legitimate additional cost to ensure the safety of your business. Or perhaps you are the one initiating the change. You're halfway through the office build-out, and you realize you desperately need more outlets in the conference room. That's a change to the original plan, and you should expect to pay for the extra labor and materials. But there is a dark side to change orders. They can be used by unscrupulous contractors to pad the bill. This is especially common with contractors who submitted a suspiciously low bid to win the job. They plan from the beginning to make their profit on change orders. You'll hear things like, "Oh, the work you wanted requires a special type of conduit that wasn't in the original scope." Or, "The city inspector is requiring an extra disconnect switch that we didn't plan for." Your first line of defense is your contract. A good contract will have a specific clause detailing exactly how change orders are to be handled. It should require that all changes be submitted in writing, with a detailed breakdown of costs, every hour of labor, every foot of wire, every single fitting, before any work is performed. Never ever approve a change order based on a verbal conversation. The moment you hear, "Hey, we ran into a little issue," your response should be, "Okay, write it up in a formal change order with the cost breakdown, and I'll review it." This puts the ball back in their court and forces them to justify the expense. When you get that document, scrutinize it. Does the cost seem reasonable? If you feel it's too high, you have the right to question it and even get a second opinion. A legitimate change order for an unforeseen safety issue is one thing. A change order for something that should have been obvious to an experienced professional during the initial site walk is a giant red flag. If your electrician says, "We need to upgrade this panel because it can't handle the load of the new equipment," your question should be, "Why wasn't this identified during the initial load calculation we discussed?" The change order is a tool. In the hands of a professional, it's used for precision adjustments. In the hands of a predator, it's a weapon to bleed you dry. Once the work is underway, you can't just be an absentee owner. You or a trusted manager needs to walk the site regularly. You're not there to micromanage the electricians, but to observe. Is the job site clean and organized? Professional crews take pride in their work environment. A chaotic, messy site is often a sign of chaotic, messy work, and it's almost always an unsafe site. Are they following safety protocols? Are they wearing their hard hats and safety glasses? This isn't just about them. It's about your liability. An injury on your property can turn into a legal and financial catastrophe. Take pictures of the progress every couple of days. This creates a visual timeline. It's invaluable if there's a dispute later about what work was done and when. You are paying for a professional service. You have every right to ensure it's being delivered professionally. And remember, your electrician is not working in a bubble. A commercial renovation is a complex dance between multiple trades. The electrician has to coordinate with the people framing the walls, the plumbers running pipes, the HVAC techs installing ductwork, and the drywallers who come in to cover everything up. The timing of this dance is everything. I once heard about a restaurant project where the electricians finished their rough-in, pulling all the wires to the exact locations for the kitchen equipment. But the project manager failed to communicate a last-minute change from the kitchen designer. The framing crew moved a wall by 6 inches. The drywall crew came in right after and covered everything up. When the electricians returned to install the outlets and switches, everything was in the wrong place, buried inside a newly finished wall. The drywall had to be torn out. The wiring had to be moved. The wall had to be repatched, retaped, and repainted. The project was delayed by 2 weeks, and a bitter battle erupted over who was going to pay for the mistake. That is a failure of coordination. A good commercial electrician acts as a quarterback, constantly communicating with the other trades to ensure everyone is working off the same playbook. Before you hire, ask them, "How do you handle coordination with other trades on a busy job site?" Their answer will tell you everything you need to know. After weeks or months of work, the tools are packed away, the dust settles, and the job looks complete. But it's not. Now comes the single most important moment of the entire project, the final inspection. This is the final exam, and the city or county electrical inspector is the proctor. The electrician is responsible for scheduling this inspection. The inspector will arrive with a copy of the plans and a fine-toothed comb, checking the work against the National Electrical Code and any local amendments. They'll check for proper grounding. They'll make sure the amperage of the breakers matches the gauge of the wire. They will verify that outlets are the correct distance apart. They will test the emergency lighting. They are the impartial third-party authority whose only job is to ensure the work was done safely and to code. If they find a violation, they will issue a correction notice, and the project fails inspection. Your contract should state, unequivocally, that the electrical contractor is responsible for fixing any and all inspection failures at their own expense. It was their job to know the code and perform the work correctly the first time. They don't get to charge you for fixing their own mistakes. Once the corrections are made, they'll schedule a reinspection. This process continues until the inspector is satisfied. When that happens, they will sign off on the permit, often placing a green sticker of approval on the electrical panel. That little green sticker is one of the most valuable things in your building. It is the official proof that your electrical system is safe. Without it, you cannot get your certificate of occupancy. Without a certificate of occupancy, you cannot legally open for business. Your insurance company could deny any future claim if they discover the work was never properly inspected and approved. This isn't just a piece of paper. It's the legal foundation of your business's physical safety. Passing that final inspection feels like the ultimate victory. The city has given its blessing, the power can be turned on, and you're ready to open your doors. But don't hand over that final payment just yet. The work on site may be done, but the project isn't truly over. There's one last phase, the project closeout, that separates the true professionals from the rest. This final step is what protects you for years to come, long after the electricians have driven away. This documentation is your shield. Imagine 5 years from now, you want to add a new wing to your building or install a massive new piece of equipment. A new electrical contractor comes in. Without a proper closeout package, they're starting from scratch. They have to spend days, maybe even weeks, tracing circuits, guessing at panel loads, and trying to reverse engineer what the previous team did. Every hour they spend doing that investigative work is an hour you are paying for. But with a professional closeout, you hand them a neat binder. In it are the as-built drawings. These aren't the original blueprints. These are the final, definitive maps of your electrical system, as it actually exists in your walls and ceilings. It shows every circuit, every junction box, every change that was made during construction. The new electrician can get to work in minutes, not days. You've just saved yourself thousands of dollars and weeks of downtime. All because your first contractor understood the power of a proper closeout. This package is your system's biography. It contains all the operation and maintenance manuals for every piece of equipment installed. That high-efficiency lighting system? The manual is in there. The new backup generator? The service schedule and operating instructions are right there. It also includes a complete list of all the manufacturers and their warranty information. If a specific, expensive piece of switchgear fails a year down the line, you don't have to hunt for a receipt. You have the warranty document, the serial number, and the contact information right at your fingertips. This isn't just about convenience. It's about leveraging the full value of the investment you just made. But the most critical part of this phase is the final sign-off. The contractor facilitates the final inspection with the local authority, the AHJ we talked about earlier. When that inspector walks through your facility and gives their final approval, it's the ultimate validation. It's the official legal declaration that your facility is safe and up to code. This isn't just a formality. That final inspection certificate is often required to get your certificate of occupancy, which you need to legally open for business. It's the document your insurance company will want to see. It's the proof that you, the business owner, have done your due diligence to protect your employees and customers. A contractor who rushes this step, or tries to bypass it, is not just cutting a corner. They're putting your entire business in legal and financial jeopardy. And let's talk about financial protection. A professional closeout includes one of the most important documents you'll receive: the final, unconditional lien waiver. Here's what that means in plain English. Your general contractor hires subcontractors and buys materials from suppliers. You pay your contractor. But what if your contractor doesn't pay their supplier for the thousands of dollars of copper wire they installed in your walls? That supplier can place a legal claim, a lien against your property. You could be forced to pay the bill twice to prevent them from foreclosing. It's a nightmare scenario that happens all too often. A final unconditional lien waiver, signed by the contractor, their subs, and their major suppliers, is a legally binding document that says they have been paid in full, and they waive any right to place a lien on your property. Getting this document isn't just good practice. It's an absolute necessity to close the books on the project and sleep soundly at night. Finally, the closeout isn't just a handover of documents. It's a handover of knowledge. The best contractors will schedule a training session with you or your facility manager. They'll walk you through the system they just built. They'll show you the main disconnects. They'll explain how the emergency lighting system works. They'll demonstrate the startup procedure for the generator. They'll label every panel clearly, so you can identify circuits in an instant. This knowledge transfer is priceless. It empowers you to handle minor issues yourself and to communicate effectively with an electrician in an emergency. The project isn't truly done until you, the owner, feel confident and in control of your new system. But even this isn't the end of the story. The smartest business owners know that the completion of a major project is the beginning of a long-term relationship. Your electrical system is like the engine in a high-performance car. You've just had it custom-built and installed. You wouldn't just drive it for 100,000 miles without ever changing the oil, would you? Of course not. That's where a preventive maintenance agreement comes in. A forward-thinking commercial electrician, the same one who now knows your system better than anyone, will offer you a plan to keep it running in peak condition. This isn't about waiting for something to break. This is about preventing the break from ever happening. A maintenance agreement can include annual inspections where they do things you can't. They use thermal imaging cameras to scan your electrical panels. This incredible technology allows them to see hot spots, loose connections, or overloaded circuits that are invisible to the naked eye. Finding a hot connection on a thermal scan and tightening it takes about 5 minutes. Letting that same connection fail could cause a catastrophic arc flash, destroying thousands of dollars of equipment and causing a multi-day shutdown. Which would you prefer? They'll test your emergency systems like your backup generator and exit lighting to ensure they'll actually work when you need them most. They'll check the torque on connections because vibrations in a building can cause them to loosen over time. They'll clean components, removing the dust and debris that can lead to overheating and fires. This proactive approach transforms your electrical system from a source of potential anxiety into a reliable, predictable asset. It changes your electrical spending from reactive, emergency-based costs, which are always higher, to a predictable, budgeted operating expense. It's the difference between playing defense and playing offense. Over these 10 parts, we've taken a journey. We started with the subtle whispers of a system in distress, the buzzing lights, the tripped breakers, the outlets that feel warm to the touch. We've uncovered why ignoring those whispers is a gamble you can't afford to take. We've navigated the critical process of choosing the right partner, distinguishing the true professional from the risky handyman by looking for the pillars of licensing, insurance, and deep commercial experience. We've walked through the entire project lifecycle. The initial call where you define your needs, the detailed estimate that protects you from hidden costs, the meticulous planning and permitting that sets the stage for success, the safe and efficient execution on the job site, and finally the comprehensive closeout that secures your investment for the future. We've seen that every single step matters. Cutting a corner on any one of them can unravel the entire thing. The central truth is this: your electrical system is the invisible architecture of your success. It powers your servers, lights your workspace, runs your machinery, and protects your people. It's the silent, tireless engine that drives your entire operation. Treating it as an afterthought is like building a skyscraper on a foundation of sand. It might stand for a while, but eventually it's going to fail. Making that call to a qualified commercial electrician isn't an admission of a problem. It's a declaration of leadership. It's an investment, not an expense. It's an investment in safety, an investment in efficiency, and an investment in the uninterrupted continuity of your business. It's the peace of mind that comes from knowing that the very heart of your company is robust, compliant, and professionally managed. So the next time you see a flicker, the next time you plan an expansion, the next time you simply wonder if your business is truly safe, you'll be armed with knowledge. You'll know the right questions to ask, the right qualifications to look for, and the right process to expect. You won't be just hiring someone to fix a wire. You'll be choosing a strategic partner to protect your legacy, your employees, your customers, and the American dream you've worked so hard to build. Don't wait for the alarm to sound. Make the smart call. Make the safe call. Your business deserves nothing less.